Today I'm going to be presenting on modern corrosion protection systems, and this is part one. Part two is going to be from Dr. McConnell, and she's going to be presenting directly after me. And today we're focusing on durability strategies, otherwise known as corrosion protection systems for steel bridges. I want to start off by saying that oftentimes corrosion protection systems are overlooked, especially early on in a design project. And I want to try to emphasize the fact that this is a very important topic. I understand that everybody wants to learn more about design and how to size beams, and that's all very well and good and very important. However, this is something that shouldn't be overlooked. It can be a very costly system if you make the wrong decisions and if you detail things improperly. And so that's going to be the focus of today, is to mainly introduce you to the major corrosion protection systems we have for steel bridges, as well as talk a little bit about some relative cost information. And Jennifer's going to talk about detailing and perhaps some of the research that she's working on in addition to some other things. So with that, I will get started here. And one thing I want to point out is that all the information that I'm talking about today can be found in the Federal Highway Steel Bridge Design Handbook, Volume 19. This is a free document available on the Federal Highway website, and it's also on the NSBA's website as well. It's a very comprehensive document and talks a little bit more in detail about what I'm giving you a flavor of today. But Volume 19 of the Steel Bridge Design Handbook is just a nice handy reference to use. You can also go to our website, aisc.org, excuse me, /NSBA/corrosion protection. You'll notice a lot of the very same topics that I'm going to discuss today, and we have a lot of references to various informational and resources that you might need. A lot of the references are Volume 19 of the Federal Highway Steel Bridge Design Handbook as well, though. So that said, hopefully you get the point that the Volume 19 there is a good reference document to use for this. So what I'm going to do here is introduce the 5 major corrosion protection systems, and then I'm going to talk a little bit about relative cost information. I'm not going to get into depth about what each system costs, more of a relative percent difference between the two, just to give you guys an idea of the relative scale of the cost of the various systems. So these are the 5 major systems available: uncoated weathering steel and liquid applied coatings, otherwise known as paint. Those are the ones that I list on the top 2, and generally speaking, those are the most common systems used. Not to say that the other ones aren't used, but I would venture a guess between 80 and 90% of the steel bridges that exist and are being built today are either weathering steel or some sort of a liquid applied coating system. Again, I'm not saying that the other systems aren't available. They are, and they're very good systems. They're just not as common as the first 2. So the third one on the list there is thermal spray coating, otherwise known as metallizing, hot dip galvanizing, and then A709 50CR, which is previously known as A1010. This is our low-grade stainless steel option, if you will. And, there we go. All right, so I'm going to make the argument that you should generally, as a default system and a rule of thumb, is start with uncoated weathering steel and then move to the next system if there's a compelling reason to do so. Again, I'm not saying you shouldn't use any of these systems. They're all good systems. They all work, but there's a time and a place for each of them. And so I would encourage you to start with uncoated weathering steel. And if there's a good reason to move to the other ones, then again, by all means do so. Just don't start with 50CR and work from right to left. I would encourage you to work from left to right. Weathering steel is a particular designation of ASTM A709. As any designation in there that ends in a W. So A709 50W, for example, is the most common grade of weathering steel. And the W here stands for weathering. Generally speaking, it's a chemical composition in the steel itself that provides this patina. And the patina forms, it looks a little bit like rust, and fair enough it is actually, but it forms this, it's a more tightly adhered patina layer on the outside that actually protects the bare steel underneath. And so that's how the whole mitigation for corrosion protection systems work there. This is just a quick look at it. Generally looks, dark chocolate or a brown color, almost a purple hue. And I am going to mention whether or not the various systems are barrier protection systems or cathodic protection. This one does tend to be a barrier protection system because the patina on the outside protects the steel on the inside. I'm going a little bit out of order here. I'm going to talk about 50CR next. Again, this is the low-grade stainless steel option. The reason I'm out of order is because 50CR tends to look a lot like weathering steel, and probably in service for both bridges, you really probably wouldn't be able to tell the difference. They're both going to look like a dark brown color. The main difference is in the chemistry. For this low-grade stainless steel, there's approximately 11% chrome included here. And one thing I want to make clear, this is not the stainless steel you think of in your appliances. That has on the order of about 30% chromium in there. This is about 11%, but it still provides excellent corrosion protection system. And as far as I know, there's only been a handful of bridges that have actually been built with this. So it's definitely a newer system. It's not very common, but it definitely exists, and it's available to decision makers and owners alike. We'll switch gears a little bit and now talk about liquid applied coatings, otherwise known as paint systems. Although you don't necessarily need to think of the paint systems of old, because there's definitely a difference between the two. Generally speaking, and what I'm showing here is a 3-coat traditional paint system. This is the most common paint system that exists today. It consists of a primer layer that is either inorganic zinc or organic zinc. The middle coat is an epoxy intermediate coat, and then there's a urethane top coat. The urethane is where you get your color and your various gloss characteristics of the entire paint system. So you can see there in the picture, there's the substrate on the bottom, then the zinc-rich primer layer, then the intermediate layer, and then the top coat on top of that. Now, one problem we've had with paint over the years is most people, when they see an old bridge that's, say, 50 years old, it might look like this. I'm calling this a misperception dilemma, mainly because this system, or this type of bridge that a lot of people have in their heads when they think about steel bridges from the old, it's an old lead paint system. This is an old system that's no longer used anymore. But unfortunately, this is the perception that people have in their head. And I'd like to encourage you to not think of this bridge when you think of modern corrosion protection systems. And I'm going to show you a timeline of some of the major events next. Up until about 1977, this was the norm. This is the very same bridge in a reconstruction project where they're building a new bridge on the right side here. And the bridge on the right, the new one, is using a modern corrosion protection system. Now, yes, I realize that that's a new paint system, so it's obviously going to look better. However, I have some pictures a little later on to illustrate it. Even the older bridges from the 90s that have used this system do still look to be in good shape. They're not the picture on the left, they're more like the picture on the right. So as promised, I'm going to show you a little timeline of some of the major events here. So up until about 1977, lead paints were very common. Lead paints were banned in approximately 1977, which is why we switched over to the new paint systems. About that same time, in 1975, is when zinc-rich primers were introduced. It's just how they sound. It's a primer that you normally would think of, except there's zinc in the chemistry of the paint system itself, or the primer system itself, that also can provide some cathodic protection for the bridge. Now, after 1977, even though lead was banned, you were still able to use it based on some exclusions. And all the way up to the late 80s, you could still use lead paint systems, which is kind of shocking if you think about it. And it's a similar time frame in the 80s, early 80s, and then we started to realize the benefits of surface preparation. So the lead paint systems, there really wasn't much surface preparation included in that process. When I say surface preparation, they actually have a wheelabrator. It's taking little shots of steel and it's shooting it at the surface of the steel, and it removes any mill scale and just cleans it very good. That became common in the early 90s, but it wasn't really introduced until the 80s. About that same time, in the late 80s, is when zinc-rich primers started to be more widely introduced. Then that leads us to the 1990s and to today. So from approximately 1990 to current times is when modern corrosion protection systems for paint systems were more widely adopted. One thing I forgot to mention there is down at the bottom, in approximately the early 90s, there were some VOC regulations, and VOC stands for volatile organic compound. And that's just it's a compound that gets released into, or a solvent that gets released into the air as the paint dries. That was an EPA regulation, and that definitely had some influence on the modern corrosion protection systems today. So the combination of blasting as well as zinc-rich primers really changed paint systems in approximately the 90s and leads us to currently what we have today for paint systems. So to reiterate, I would like you to get this image out of your head and get an image like this in your head. Now, this is not a sexy looking bridge. It's a simple plate girder, just an interstate grade separation, but it uses a paint system from about the late 80s. or sorry, the late 90s. And this is a modern 3-coat paint system. And this is a picture taken from Google Maps about a week ago. And so you can see that it still looks to be in good shape today with no evidence of any sort of corrosion forming there. So this is the modern corrosion protection system. So this is what I would encourage you to think of when you think of paint systems. Typically, these are barrier systems. However, the zinc-rich primers do provide some cathodic protection if it's exposed. So that's if the intermediate and the top layer, if it's a 3-coat system, do get deteriorated, for example, and the zinc-rich primer is exposed, then it will provide some cathodic protection as well. This slide is meant to illustrate the difference in coating thicknesses of the major paint systems. The two systems on the right, OZE and U, and then IOZE and U, are the traditional 3-coat paint system. The x-axis here is the overall coating thickness in mils, and you can see that a 3-coat paint system is approximately 25 mils thick. And then over to the right is a single coat of IOZ. You can use a single coat of IOZ as a corrosion protection system. It provides a lot, or actually pretty significant cathodic protection as well. But the thing I want you to understand here is that there are some cost implications. So when a fabricator is fabricating a plate girder, for example, after it's done being fabricated, it goes into their paint bay. And if you have to apply three different coatings, then it's going to take a little more time for the coating system to dry that was previously applied, and then to apply the next one. But the main thing I want to point out here, and I think you can see my cursor, is up here. When you use an IOZ coating in a 3-coat system, it's very dependent on the relative humidity and the temperature for that IOZ to cure. Now down here, this is also IOZ, but this is just one coat. The fabricator can simply take this bridge after it's coated, move it out of the way, and it doesn't affect their throughput, and therefore doesn't cost as much. So generally speaking, the more layers you have, the more time it's going to take to apply, and therefore that's going to cost money. So you should always reach out to a local fabricator and talk to them about what their shop is set up for and what they prefer. That's usually going to be a good cost-saving measure to do for any decision maker. I mentioned that the workhorse systems are the 3-coat systems, and they definitely are, but there are some newer systems that are available as well. So a single IOZ coat, that's something that we're currently researching. There's also some 2-coat systems that are made up of IOZ as the base layer and then an acrylic top coat. Then there's also one that uses an organic zinc primer and a polyaspartic top coat. The organic zinc primer is supposedly easier to apply, and it cures a lot more consistently than an OZ primer does. So that's gaining some popularity, especially in the Northeast. An example of that is the Tappan Zee Bridge. This is an outlier. I admit that this is one of the biggest projects we've had in the US for some time, but they considered metallizing and using inorganic zinc and organic zinc primer for their 3-coat paint system early on. They chose to do organic zinc mainly due to time savings. Just simply choosing organic zinc as the primer for the 3-coat paint system saved approximately a year to a year and a half in the overall construction schedule. So you can see how much time it saved and therefore how much money it saved just by making that decision. Okay, next I'm going to talk about thermal spray coatings, aka metallizing. When you think of metallizing, think of a combination of welding and spray painting. So you have a spray paint gun, for example, and there are some wire electrodes fed into it. There's an electric arc passed through the electrodes, and then that melts the wire, and then there's compressed air that blows the droplets of metal onto the surface of the steel. And by far, 8515 is the most common, but that doesn't mean that the other ones don't exist. 99% aluminum is definitely available and is used in Florida, from what I understand. And then there's 99% zinc used as well. This is just a picture of what these look like. They tend to be gray in color. These are the 99% zinc on the left, and then also the 8515 and the aluminum on the right. So generally, though, it's gray in color. You may or may not have to use a sealer. They're not necessarily required, but they are sometimes used. So this is a detail here of the substrate on the bottom, the TSC in the middle there, and then a very thin layer of sealer on the top. Now, whether or not you have to use a sealer is somewhat dependent on the state that you're in, and it also depends on the thickness of the TSC itself. The thicker the coat, the thicker the thermal spray coating, the less chance that you have to actually have to use a sealer in the end. This is a mechanical process, whereas hot dip galvanizing on my next slide is a chemical process. So hot dip galvanizing is definitely a common corrosion protection system that's used. It's typically used for smaller bridge girders, though. It's not used for big, huge plate girders just because the tank sizes aren't very big, but it's definitely very common and a very effective system for the shorter bridges that are used for, or the shorter girders that are used for bridges. The American Galvanizing Association is the best place to go for information on this, and their website's on the bottom at galvanizeit.org. But generally speaking, you take steel and you dip it in molten zinc. It's approximately 830 degrees. There's a chemical reaction here, and it mixes the outer layer of steel with the zinc layer, and they kind of interact with one another and form a chemical bond. And the reaction is complete, though, when the steel temperature reaches the same temperature as the zinc bath that it's in. This is a little bit on the surface prep that goes into this. So there's three major stages of surface prep: degreasing, pickling, and fluxing. And then after that's done and it dries, then it can be dipped into the zinc bath. But only until that happens can it actually be dipped into the zinc bath. And this is a little bit more information on what happens in these various stages of surface preparation. So the degreasing just removes dirt and oil and any organic, dirt, if you will. Pickling removes any mill scale, which in a paint system, for example, that's taken off by a wheelabrator. And fluxing is just a mild cleaning and then a protective layer. But if you don't clean it properly, then the unclean areas won't grow as zinc coating. So that's very important to do and very important to the overall process for hot dip galvanizing. Okay, now I'm going to talk a little bit about relative cost of coating systems, and then I'll pass it over to Jennifer and she'll finish us off here today. So the chart that I'm going to show on the next slide is from information obtained from our member fabricators, and it's their perception or their understanding of the relative percent increase over 50 grade weathering steel. So 50 grade is the baseline, and then they have a percentage difference in between 50 grade weathering steel and the rest of these systems. So this is just a percent difference here. Along the y-axis there, you see the percent increase over weathering steel. On the x-axis is the various systems. This is a box and whisker plot. So what that means is the boxes that you see there, the gray and the blue boxes, represent the middle 50th percentile of the responses. The tick marks represent the min and the max. So I'm going to use my cursor here, if I can find it. There it is. And these three systems over here, various variations of weathering steel and single coat IOZ, tend to be about a 6 to maybe 8% increase over weathering steel. Our typical painted systems tend to be about 10 to 20% more, and then hot dip galvanizing and thermal spray tend to be about 20 to 30% more. But this is a very regionalized. So in some parts of the country, thermal spray is common and it's not quite as expensive, but other areas of the country, it is not as common, and that's what drives up the cost, especially for thermal spray over here. So there tends to be more variability because it's dependent on a lot of different factors for these other systems. So generally speaking, though, those are the relative scale of cost differences. I would like to recall or us to remember this slide. So generally speaking, I would recommend we start with the weathering steel and go to the other systems if we have to. Now I'm going to run through an example, and I'm going to use weathering steel as the base cost. And then I'm going to run through an example to illustrate the cost differences of paint, thermal spray, galvanizing, and 50 CR. Actually, I don't think I do 50 CR. I think I just do paint and thermal spray and galvanizing. So let's pretend we have this bridge. This is a real bridge. This is an image from a colleague of mine, Tony Peterson, in Des Moines, Iowa. He actually helped design this bridge, I believe, about 20 years ago. This is a weathering steel bridge on an interstate in Des Moines. So it has two equal spans of approximately 175 foot each, 60 feet in width. So therefore, the total area of this bridge is approximately 21,000 square feet. Now, I'm going to make this calculation based on a cost of corrosion protection based on weight. Typically, corrosion protection systems are based on surface area, with the exception of galvanizing. But we do have some estimates for cost of corrosion protection systems based on weight, and that's what I'm using here. Again, this is just for illustration purposes. So what you see here is our weight to span curves. This is a free document that we have on our website, but you can use it to estimate the weight of superstructure steel if you know the span length, the girder spacing, and the number of spans, of course. So for a 2-span bridge, about 10 feet girder spacing, 175 feet in length, the weight of the steel should be approximately 35 pounds per square foot. Multiply that by the area of the deck, and that yields, approximately 735,000 pounds of steel. So now for a routine straight steel bridge, for again, for illustration purposes only, let's assume that it costs for fabrication and delivery $1 a pound. Again, this is for illustration only. I just want to make the math relatively easy. This isn't too far off, but I want to make the math relatively easy so I can illustrate the cost differences of the systems. So $1 a pound times 735,000 pounds, we can all do that math, $735,000 for the cost of fabrication and delivery. I want to point out that this doesn't include the construction of the bridge itself. But here's some summary of the cost differences. Again, our baseline is 730 grand for weathering steel. But now let's look at these other systems. So this is single coat IOZ. This is the 3-coat system with using organic zinc primer and then thermal spray and hot dip galvanizing. Again, this is just ballpark estimates. I'm going to say approximately a 6% increase for single coat IOZ, 13% increase for the 3-coat paint system, and 30% increase for thermal spray or galvanizing. Again, we can all do this math because our baseline is $1. So $1.06, $1.13, and $1.30 a pound now for our various costs. You can see the total cost here, but then you can see the difference for the baseline. So this is just simply 779 minus 735 is all this is. You can see the difference here. Now, there might be a very good reason to use hot dip galvanizing or thermal spray. You might be right directly over some salt water, for example, and so therefore you would want to use that. You wouldn't want to use weathering steel. However, just make sure that you understand the cost implications of if you do that. If you're in a rural area in anywhere interior US, I would highly recommend you consider uncoated weathering steel. But if you need to use paint or single coat IOZ or thermal spray or galvanizing, then again, by all means do so. Just understand that there is going to be a cost difference with that and understand what that will be. So with that, I believe I'm finished. You can see my contact information there. Carlson at steelbridges.org if you have any other questions that we don't get answered today. And we always have, you can always see our website for more information as well.